Our research team has been monitoring the very small earthquakes, micro-earthquakes, in another volcanic system called Askja, which is just north of the one that's erupting. And so we've had earthquake detectors, they're called seismometers, deployed for 8 years now. And we've been mapping the molten rock under this other system called Askja, and we found quite a lot there. It's not erupted for a few decades, but as it happened, this year we had a maximum number of seismometers deployed. There was about 70 of them. When this other eruption started from the volcano, which was about 60 kilometres to the south. And it just so happened that this molten rock moved underground and it moved northwards directly into the middle of our detection array. So we couldn't have done it better, actually, because it was all there, it was all working, and it just recorded everything. And that's just good fortune, really, because we had a different target, but it happened to be in the right place at the right time. And a bunch of my PhD students were out there doing the servicing. I wasn't there, actually, I was back in Cambridge at the time when it started. And they realised this was going on, and we happened to have 15 spare seismometers, and they rushed out and they put them just over where we could see this molten rock was moving northwards. And they finished deploying really late at night. I think it was dark, it was about 10 o'clock at night before they went back to the hut. And the eruption started just after midnight following that, so a couple of hours later. So they got the whole array deployed exactly over where it erupted. So that is brilliant. You couldn't have planned it better.
The opportunity to get kind of up close and personal to a lava flow or the fountaining themselves was incredible. The sound of it was especially like something quite special. Especially that first eruption, which was very small. I must have been one of like 12 people who saw it, which is quite an odd feeling in many ways, but still quite exciting nonetheless.
This was an amazing experience for me, and I think for everybody there, actually. I've worked on volcanoes and earthquakes for 40 years, and I've never seen an eruption close up. I've been in one little earthquake, but never felt an earthquake otherwise. So professionally I knew all about it, technically, scientifically, but actually experiencing it just is a visceral experience, if I can put it that way, because it assaults all your senses at once. At the moment, as I speak, it's erupted 200 million cubic metres. The amount of melt in it would bury Cambridge about 30 metres deep. So it's a lot of molten rock. Or to put it in another way, it's erupting 400 tonnes of molten rock every second. And it's a huge amount of energy. It's equivalent to, in energy terms, to a Hiroshima-sized nuclear bomb going off every 2 minutes. Not just once, not just twice, but hour after hour, day after day, week after week now. So it's just a huge amount of energy. I think the data set we've got from this eruption is probably one of the best in the world ever. Because of course there's not only us working there, there's Icelandic scientists who also have seismometers spread over other parts in Iceland as well as around here, because it's a very seismically and volcanically active place. And of course data collection is so much better now than it was even a decade or two ago. And so probably it is one of the best documented eruptions in the world, and our data set is just part of that, really.